Hey, hey, welcome back. We are going to continue the Algebra 2 Common Core examination. This is from June 2017, and we're going to finish this off by doing problems 33 through 37, the last 5 problems. Let's go. This is a great problem to start with. I cannot wait to do this. However, we could do it all in the calculator. What do I mean? I have 3 variables, x, y, and z. I have 3 unknowns with 3 equations. So, first off, I want to make sure I know the coefficients or numbers in front of each variable. 1x, 1y, 1z. Okay, this is negative 1x, 3y, 5z. Okay, so I have numbers everywhere. I'm going to, actually, let's write this first. I'm going to use the matrix function in the calculator. And what I'm going to do is the following, right? I'm just going to put the numbers without the letters, without the variables. Notice I have a 1, 1, 1, and 1. So 1, 1, 1, and 1. If you're not familiar with this, my x's go in this column, my y's go in this column, my z's go in this third one, and whatever the equation is equal to goes in the last column. So let's try the next one. We have 2, 4, 6, 2. 2, 4, 6, 2. And last but not least, we have a negative 1. Don't forget that if the sign is negative, you need to carry that. A positive 3, a negative 5, and it equals 11. This matrix that I have on the board, I don't need this, obviously, is what I put in the calculator. Not only is it what I put in the calculator, by writing this down, I am showing work. Okay, that is enough to show your work. So let me show you right in the calculator where I put that stuff. Turn this on, and you will see above the, you see the sign button in the calculator? It's right here. To the left of that in blue, it says matrix. So I hit second matrix. Now, first of all, I want to edit a matrix. So I'm going to go to edit. And you can pick any one of these. Let's just pick A. It's the first one. If you want to scroll down to V for Visca, I'd be honored. But now I need to make my matrix 3 tall by 4 wide. So you see where the cursor is. It's 3. I hit enter, and 4, enter. Oh, it's beautiful. And this top row is all 1s. Make sure when you enter them, they actually get inputted. The next was 2, 4, 6, and 2. And the last one was negative 1, 3, negative 5, and 11. Boom. I got to hit enter that last time. Here's my matrix. It looks beautiful. So now I quit. I actually have to quit out of here, and I need to go back to the matrix menu. No, I lied. Yes. No, we're good. And I go to math, and I'm going to scroll down until I see choice B is R ref. Notice there are 2 R's to start. I don't want the one with 1 R. Okay, choice B, the 2 R's. So I select that, and all I need to do is put my matrix in there, meaning I go back to matrix a 3rd time, and see the ones that are named? I put it in the first one, A. You can see it's 3 by 4. Okay, so I hit enter. It is going to do this RREF, or solve matrix A, and this is the solution. Okay, this is a solution matrix. So for poops and giggles, we need to write that as well. So put an equal sign. That's going to be 1, 0, 0, 0. That's the first column. Then a 0, 1, 0, 2. And then a 0, 0, 1, negative 1. Now, these right here, these numbers, they are the solutions. My x, all right, let me get this out of here. Go. It's not that I don't love you. I'm done with you. Okay. Remember, these are my x's, my y's, my z's, and what they equal. 1x without any y's or any z's equals 0. So x equals 0. 1y with 0 x's and 0 z's is going to equal 2. And 1z, okay, without any 0, any x's or y's, is going to be -1. There you go. So I used to be one of those teachers that used to do the algebra on this until I had a student take this study course and came back to me. He told me about this matrix function. And on the exam, if you write your matrices out, as I have here, this is showing credit, showing work, and giving you full credit. Boom. Oh boy, Jim's looking to buy a vacation home for $172,600. Yeah, good luck. If he could find a trailer park home, he'd be in some slum for that much money. He'd be okay. The housing market's crazy, kids. Anyways, near his favorite southern beach, on the beach, no less. Oh, 2017, where did you go? The formula to compute a mortgage payment M is M equals P times this whole R times 1 plus R to the N, all over 1 plus R to the N minus 1. Where, and this is where it gets important, P is the principal amount. Boom. Okay. The mortgage payment is your M. Okay. R is the monthly interest rate. So that's going to be in 3 spots. And N is the number, yep. The number of monthly payments is N. There you go. So we now have data for each variable here. Jim's bank offers a monthly interest rate, okay, a monthly interest rate of 0.305% for a 15-year mortgage, right? With no down payment, okay, with no down payment. Determine Jim's mortgage payment rounded to the nearest dollar. If there is no down payment, that means he is borrowing this in full. He's not putting any money down to reduce this amount. That's what he's borrowing in full. That's going to be the principal amount of the loan. Okay, my P, 172,600 times my rates. Okay, my rates currently is 0.305%. But we want to put my value of a rate into my formula without the percent. So I got to divide that by 100, and that'll give me 0.00305. And if you want to put a 0 in front, you can. Now the percent's gone. That's actually going to be my rate. Oh, my God. So 0.00305 times 1 plus the rate, 0.00305, raised to the N, the number of monthly payments. In 15 years, how many months? Well, each year is 12 months. Is it 180? 180 months are in 15 years? Let's check that. We have a calculator for this whole test. So I'm going to turn this on. 15 times 12. 180. It's 180 months. So my N is 180. That's going to be up here. All over 1 plus my rate, 0.00305, to the N, 180, minus 1. I literally got to put that all in the calculator and hit enter. Oh boy. And we got to round that to the nearest dollar. All right, so I have 172,600 times, let's get a fraction going here because we can. Nope. 172,600. Pop off. Alpha y equals enter. Yeah, you son of a gun. 172,600 parenthesis. Alpha y equals enter. And the top is 0.00305 parenthesis 1 plus 0.00305, parenthesis, raise it to the 180, all over. Let's do it again. Parenthesis, 1 plus, is that a plus? It is. 0.00305. How many times are you guys going to hear me say that and not get sick of it? Pop off minus 1, close that parenthesis. That's a lot. But we have $1,247.49. 1247.49. They want it to the nearest dollar, which means this will stay $1,247 monthly payment. We're not done because there's a second part here, kids. Algebraically, oh my God, we got to do this algebraically. Algebraically determine and state the down payment rounded to the nearest dollar that Jim needs in order for his mortgage payment to be $1,100. So let's say Jim, God bless him for buying that home, he wants his payments to be $1,100. All right. Okay, he wants his M value to be 1,100. Right here, that's going to be 1,100. So obviously this is going to have to be a little bit less, right? The smaller this number is that he borrows, okay, the less he's going to have to pay back. So what amount is he going to have to borrow in order to make my equation be 1,100? Once I know that, let's say it's 150 grand. So I can say, well, how much is it going to have to put down? Like, how much is it going to have to pay toward this 172 so that I can make it small enough, or I can lessen it so that it becomes the whatever amount would make this $1,100. So let's start, shall we? 1,100 is going to equal some amount I borrow times, oh my God, here we go again, 0.00305 times 1 plus 0.00305 raised to the 180, because nothing else is changing, all over 1 plus 0.00305 raised to the 180 minus 1. Okay, so the very first thing I'm going to do, is I'm going to figure out what is this value. See how these are all numbers? I'm just going to put this in the calculator and hit enter. And I'm going to put that right here. Okay, if you guys don't mind. Oh, is there a way I can do this without retyping everything? Oh, skip, yep. There we go. There it is. Get rid of these, all three of them. I'm going to go up here and hit enter. And then I'm just going to delete that 172,000 in front. I think that's a lot easier and quicker. Maybe not. Delete. There we go. That's what's in my fraction. Oh boy. That is 0.00723. We'll just call it 0.0072 for right now. 0.0072. Now, in order to find P, all I got to do is divide both sides by that. Now, this cancels. In your calculator, don't shorten this decimal. Actually take my 1,100 and divide it. Go up here and highlight this. Boom. Okay, divide it by the whole thing. So let's not round yet. All right, I was actually close. I said 150,000. $152,193.19. Who? So my P needs to approximately be $152,193.19. This is what my P value needs to be in order to have a payment that's $1,100. So they're not asking you what the borrowed amount is. They're asking you what does he need to put down? What's his down payment? So if my house that I want to buy is $172,600, how much of that money am I going to have to pay up front so that it will become 152, 193.19. What is the difference? So I'm going to take my 172, 600 and just subtract this. And whatever amount that comes to, that's the amount I need to pay toward the 172, 600 to get my payment to be $1,100 a month. So we're back here. 172, 600. Let's subtract my 152, 193.19. He has to put down $20,406.81. $20,406.81. Okay, they want this to the nearest dollar. So he's got to put down $20,407. If he has this money to put down toward this 172, then what's left is what he's going to have to borrow. That's this. And if that becomes the P in our formula, that means he'll only have $1,100 a month to pay. Woo! Please, for the love of God, I hope you get something like this. Okay? Graph y equals log base 2 of x plus 3 minus 5 on the set of axes below. Use an appropriate scale to include both intercepts. Okay? Both intercepts. So they want to see the graph actually cross the x-intercept and cross the y-intercept. So you might have to use a different scale that's not by ones in order to show both of those. So first thing I'm going to do is I'm going to graph this bad boy. Let's clear everything out. And I've got to put log base 2. Do not press log. I cannot put a base between the G and the parenthesis. Okay? I actually go to alpha window and log base is choice 5. Log base 2 of x plus 3. Pop out of the parentheses and then subtract 5. If I graph this, this is a standard 10 by 10 window. I cross the y-axis, but let's see. Ooh, I don't see the x-axis crossed yet. So what I'm going to do is I'm going to go to my window, and I'm just going to go to x is 30, and I'm going to go by threes, so I don't see 30 tick marks. I'll actually still see 10 tick marks. If I count by threes to 30, I'll see 10 tick marks. So there you go. I crossed there, and there, and there. Am I going to see it? Yeah, kind of, sort of, kind of. I got to figure out what that x-intercept is. Let's go out to 36. Graph. Now let's see if I cross it. Now keep in mind, these go by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27. Here's 30. Okay, so it looks like it crosses pretty close to 30. And that's what I'm going to use. The scale for my x-axis is going to be by threes. My y, I'm going to keep that by ones because it looks like it's right between -3 and -4 on the y-axis. But on the x-axis, it looks pretty close to 30. So why don't we just use our zero function and take a look at it? It says be anywhere to the left of my 0. There you go. Now I got to go anywhere to the right of my 0. Keep on going, my friend. I hit enter. And I hit enter one more time. Okay, that crosses right at 29. Okay, so I can go by threes to 30. And it will include my 29 here. All right, that's good. So let's create this scale here. -1, -2, -3, -4 on my y-axis. We got 3, 6, 9, 12, 15, 18, 21, and then we'll go to 30. Okay, so I cross between 3 and 4, and right at about 29 right here. It's pretty close. And I'm just going to kind of do this thing where it goes down like this. Comes. There you go. And, you know, there was this thing where teachers used to get pissed when kids wouldn't label. So I'm just going to label this. I'm not even sure if I'll lose credit or not if it's labeled or not. But I'm going to put it there anyways because I just want to make sure I get credit. And look, there you go. That's it. I mean, if you want to plot some points in between, that might not be a bad idea. Actually, I think there's a point at, well, whatever. If you want to plot some points in between, that it would not be a bad idea just to make sure it's accurate. All right. Now, what are they asking us down here? Describe the end behavior of the given function as x approaches -3 and as x approaches positive infinity. So as x approaches infinity, or as I go to the right side, this y, as my graph goes this way, it will slowly go up forever. I know it doesn't look like a lot, but it will actually go up forever. So I would say y, yeah, they give me y, not f of x. Y would also approach positive infinity, goes up forever. But as x goes to -3, okay, here's -1, 2, as x approaches this, -3. I mean, this line is just going to keep on going down and down and down forever. Okay, so my y would approach -infinity. Number 36. 2 more problems left to do. Charlie's automotive dealership is considering implementing a new check-in procedure for customers who are bringing their vehicles for routine maintenance. The dealership will launch the procedure if 50% or more of the customers give the new procedure a favorable rating when compared to the current procedure. The dealership devises a simulation based on the minimal requirement that 50% of the customers prefer the new procedure. Each dot on the graph below represents the proportion of the customers who prefer the new check-in procedure, each of a sample size of 40 simulated 100 times. Okay? Each one of these dots represents a computer simulation where they ask 40 people. So this dot is a simulation where they ask 40 people. This is another 40 people, another 40 people, and so forth. All these dots, that's what they represent. Okay, and there's 100 dots because they did this 100 times. Okay? Assume the set of data is approximately normal, and the dealership wants to be 95% confident in its results. Determine an interval containing a plausible sample values for which the dealership will launch the new procedure. 95%, I call that the moneymaker, kids. That means anything that's normal or should happen or should occur that is not unnormal, that's not unusual. Everything that's usual happens within 95%. We just take my mean and I add and then I subtract 2 times the standard deviation. That will give me the interval. Right? And they give me the mean and they give me the standard deviation. Holy smoky dokes, kids. So let's just do this right here. Clear this out. Oh, that's a beautiful orange, but we're going to not need that. Clear this. We're going to take the mean, which is 0.506. We are going to add 2 times my standard deviation, which is 0.078. Boom. That gives me 0.662. Now I'm going to do the same thing, but I'm going to subtract 2 standard deviations. Minus sign. Boom. 0.35. So let's bring this out here because it feels like it's going to be important. And I'm going to put 0.506 plus or minus 2 times 0.078 to the nearest hundredth, 2 decimal places. This will just say 0.66. So from 0.66 to 0.35. 95% of all outcomes will fall between those two proportions, and that's normal. Anything in that interval is normal. Okay. Remember what our chart represents. Our chart represents the proportion of customers who prefer the new check-in procedure. Okay. Actually, each dot in the graph below represents a proportion of customers who prefer. So this in here are the people that want it. Okay, those are the people that want it. So 40 customers are selected randomly to undergo the new check-in procedure. And the proportion of customers who prefer the procedure is 32.2%. 5%. The dealership decides not to implement the new check-in procedure based on the results of the study. Use statistical evidence to explain this decision. Okay? Statistical evidence can be this thing right here. Okay? Our 95% falls in between 66%, that's our 0.66, and 35%, that's our 0.35. That's what we're getting from above. Okay, those are considered good, right? Those are the people that want it. Okay, so why is a dealership deciding not to do this? Because, since 32.5% or 0.325 is not within our 95%. That's called a confidence interval. What do they call it up here? 95% confident. It's a confidence interval. Confidence interval. That's why they're deciding not to do it. Okay, 95% falls between these two percentages. Their percentage they got is not in that 95% confidence interval. So that's why they're not going to do the new check-in procedure. And here we go, kids. This is the big 6-point question. Number 37. A radioactive substance has a mass of 140 grams at 3 p.m. and then 100 grams at 8 p.m. Write an equation in the form of A, which is the end amount. Okay, this is an exponential. The end amount, it's like a growth and decay thing. Here's the beginning amount. Okay. H, they're telling us, H is a constant representing the number of hours. Yep. Nah. Number of hours. That's my H. In the half-life. And A sub 0 is the initial mass. We just went over that. A is the ending mass, the mass in T hours after 3 p.m. So it looks like we have T, which is hours after 3 p.m. Okay, so we have like these two time things here, which seems weird. All right. So using this, well, first of all, they're asking us to write an equation. Let's not skip that part. Write an equation in the form of blah, 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 blah. All right. So, first of all, what is my initial mass? Well, they're telling me at 140 grams, that's what I'm starting with. So my A is going to equal my initial mass, 140 grams. 1/2. Okay. Now, if I am going to check this out at 8 p.m., it's going to represent the situation. It started at 3. I'm checking it out at 8. That means 5 hours have passed since 3 p.m. So my T is going to be 5. So it's going to be 5 over H, the starting time. Okay? They want us to write this equation, okay, representing the number of hours in the half-life. Okay, there you go. That's all we have. We don't have H. I mean, I guess H is going to be the constant representing the number of hours in the half-life. We don't have that yet. So my equation, okay, is A equals 140 times 1/2 to 5 over H. And if they want me to represent this exact situation, my A should be 100. So technically, I should write it like that if I'm going to represent this exact situation with the 140 and the 100. All right? So using this equation above, solve for H to the nearest 10 thousandths. That's 4 decimal places. All right? So what I'm going to do is, first of all, I got 100 equals 140 times 1/2 5 over h. I'm going to divide both sides by 140. Zeros go away. We'll leave it a fraction for now. Let's see if it comes out something nice, a decimal that's nice. 100 divided by 140. It does not. So we'll just do math, enter, enter, reduce that. It's 5 over 7. Okay, kids, logs and natural logs. They bring exponents down. All right, so I now have the natural log of 5 over 7 equals 5 over h times, because this is going to come down now. That's what logs and natural logs do, the natural log of 1/2. All right? Let's divide both sides by the natural log of 1/2. And now this goes bye-bye. I want to solve for h. Oh, man, I'm going to have to do 2 more steps here. I'm going to have to flip them both. Yeah, I can cross multiply or flip. There is a little thing I like to do. If I got the ln of 5 over 7 over the ln of 1/2. Now, you can cross multiply and divide. That's fine. But what I like to do is if I flip one side, if I flip this and I get h over 5, I can flip the other side and it's still the same thing. The ln of 1/2 over the ln of 5 over 7. All right? Now there's only one thing left to do. I just multiply both sides times 5. Multiply this whole thing times 5. So in my calculator, I'm going to put this side. Okay? We got, clear this out, alpha y equals, enter. It's the ln of 1/2 divided by the ln of 5 divided by 7. And then I'm going to multiply that times 5. And I'm going to get 10.3002. Remember, I want to go 4 decimal places. 10.3002. That was quite a bit for a small problem. There was a lot going on there. Okay. Now, last but not least, we're on to the end. Thank God. Determine when the mass of the radioactive substance will be at 40 grams. Round your answer to the nearest tenth of an hour. There it is. All right, so here we go. I am now finding, all right, I'm now finding the t given my h right here. Okay, so I've got, okay, now my ending amount should be 40 grams now instead of 100. 40, I started with 140 times 1/2. And I've got t over 10.3002. All right, let's go. First of all, we're going to divide both sides by 140. 2/7. And I have 1/2 t over 10.3002. Again, I need to take the ln of both sides. And my exponent will come down. So let's rewrite this. Got the ln of 2 over 7 equals t over 10.3002 times the ln of 1/2. Ooh, again, I mean, this feels like we're doing the same thing, times the ln of 1/2, or excuse me, divide by the ln of 1/2. And now all I've got to do, now this is bye-bye, is really just multiply both sides by 10.3002. What I do to one side, I have to do to the other side. So in my calculator, I'm just going to put this. This goes bye-bye. All right? So here we go. We're doing good, kids. 10.3002 times alpha y equals, enter, the ln of 2 divided by 7 over the ln of 1/2 Guys, I'm nervous. 18.616. Time is approximately 18.616. Rounded to the nearest tenth of an hour. So we'll call that 18.6 hours. We are done. A lot of uses for natural log there in that last problem, but we nailed it. Good luck on the exam, kids.